I want to go through this last part very quickly. Okay, so we have come through these questions before in the lab, guessing number game. So you are given some secret integers between 0 to 99 inclusive. And as a developer, you are asked to create a simple guessing game. They ask user to enter integers. If user integers match the secret integer, output that you win and exit the game. And if the user enter is less than the secret value, your guess is too low, and then you try again. Otherwise, if the user integers is greater than the secret value, print your guess is too high and try again. And then you are say that you will be given 10 trial. Afterwards, you output, you lose. So assume that user enter integer between 0 to 99 inclusive. So when you create an application, you always make certain assumptions first so that you don't cloud your code with a lot of validity checking whether the user entered the right integer within the range or not. So we make an assumption to make it simple. Okay, so I'm going to write this code very quickly. So the whole idea is to help you to see the concept of binary search also applies here in this type of scenario. Okay, so let's say the secret integer is some random value between 0 to 99 inclusive, so 79. And of course, this is hidden from the player. And of course, whenever you run, you can make it into random. So for example, I'm going to set it first, and then later I'm going to change it into a random value between 0 to 99. Okay, and I'm going to create here. Okay, I will experience 10 trials, so I'm going to run the for loop. All right, 10 times. This will generate integers from 0 to 9, so you're going to run 10 times. Okay, for each time, you're going to ask user for a guess. Okay, so because I always assume that user input an integer, so I'm going to typecast it immediately. Okay, so my user input is always an integer. Okay, so if user input is equals to the target's secret integer, okay, what do we here? You win and exit the game. Okay, you're gonna print, you win, and then exit the game means you break. You stop asking user for input. Okay, now else if there are only two other options, whether it's less than secret integer or more than secret integer. Okay, so this is the same as what we have seen earlier. All right, if it's equal, we break. We print something that we have found it, you win the game, break. Else, there are only two options. Okay, so we're gonna look at these two options. Else if user input is less than secret integer. Okay, so what can you print? You're gonna say that your guess is too low and you ask the user to try again. Okay, so your guess is too low, try it again. So we're gonna print this and we don't break because we asked user to try again. And then else, the only possibility, if it's not less than, is greater than. So the user input is guess too high. Okay, so we're gonna print this. Again, we ask it to try again. Okay. All right. And at the end, okay, if user has not winned, okay, if not has won, all right, then you're gonna ask the user, you output, you lose. Okay, so you're gonna print, you lose. Now again, when I put has won here, or has win, you need to first set it to false. It has not win yet until you win. Okay, until you found a match between user input and secret integer, then only you output true. Then only you change it to true. So at the beginning, it's not true, it's false, and only after user input, after user enter an integer that is equal to secret integer, you make it into true. So again, it's the same principle that you have learned. Start with false. If you found equals, then you set it equals to true. And of course, you can print something to indicate that you already win, and then you break. Okay, so let's try this, okay? So enter integer from 0 to 99 inclusive. All right, so I'm gonna be smart here. I have learned binary search. So instead of starting with random integers, I'm gonna be more strategic here. So I'm gonna start with the middle value from 0 to 99. So I'm gonna apply my binary search strategy. So essentially, I'm searching for this secret integer here, but I don't know what is this secret integer. So I'm gonna do a guess, but I don't want to guess randomly. I want to be more strategic in it. So from 0 to 99, I'm gonna guess the middle value, say 50. Okay, then it's tell me that, hey, your guess is too low, try again. So I know immediately 51 to 50 is not the right answer. It's not the secret integer because it's too low. So I'm gonna start with 51 to 99 inclusive. Okay, so which means I'm gonna do 99 plus 51 divided by 2. I'm gonna take my range has shortened from 1 to 99 now to 51 to 99. Okay, so I have shortened it. I couldn't run it now anymore. So 51 to 99, let's say is 75. 75. Okay, let's see. And again, it said that your guess is too low and try again. So now I know my range has to be from 66 to 99 inclusive. Okay, so now I know I don't have to try anything below 76. So my range of guessing keep getting smaller and smaller by half. Okay, so 76 to 99. So I guess my half point in the middle value of the half point, I will guess, for example, 85. Okay, your guess is too high, try again. Okay, which means now 85 is too high. All right, so what I'm gonna do is that I'm gonna guess from 66, 76. 75 is too low, so it has to be above 75. So 76 to 84. Okay, and again, you guess the middle value between 76 to 84. I will guess 25. So you get the middle value, say 80. And then you say your guess is too high, try again, for example. And then, so again, so earlier on 76 to 84 is too high. So I'm gonna drop it down to 79. 76 to 79. So say the middle value is 78. And again, your guess is too low, try again. So it has to be from 79 to 79. So I keep reducing my search space. All right. So now what I have 77 to 79, the only range possible is 79. And then I get you win. Okay. So basically every single time I'm not doing a random guessing. I'm being strategic here. I take the middle value of the search space. Every time it gives me a hint whether it's too low or too high. And then from this information or this hint, I reduce my search space by half, which allow me to guess strategically in the minimum number of ways. Okay, so we have guessed 1, 2, 3, 4, 5, 6, 6 times. Okay, so in other words, okay, if I apply binary search strategy to this game, okay, I guarantee to get a solution. I guarantee to win after making 7 guesses. Okay, so again, how do we know it's 7 guesses? We just try it out, but for enough. So if you remember, for binary search, the number of times that we need to run the binary search is mat.log, is the logarithmic of the range here, which is 100. 0 to 99 for, let me see. Which is above 6. So if you are making 7, it's guaranteed that if you apply binary search strategy in this game here, you will win after making 7 cases, at most 7 guesses. Okay, at most, after making at most 7 guesses, you will guarantee win. And remember, the game is that you are given 10 trials. So which means you have found a winning strategy. Okay, So since the game runs for 10 trials, you have found a winning strategy. So regardless of what is the secret integer, okay, this secret integer can be made random. Every time you play the game, it will generate a different secret integer. Okay, so we can use, for example, import random. Okay, and then every time you run the game, we're gonna make it into a different integer every single time. All right, so random.rand int 0, 99. Okay, so every time you run it, the value of secret integer will be different. So you don't have to know about this random library. So you can just use it as it is. You generate random number every single time you run. So when the user play the game, every single time, it will generate a different integer. All right. But regardless of what is this secret integer, if you apply the binary search strategy to this game, you guarantee to win, because you have this strategy that will always win if with just at most 7 guesses. And this game run for 10 trials, so you actually will always win if you apply that binary search strategy. Okay, so what does it mean is that this game, you can always win. There is a winning strategy. So from the user point of view, they just have to be smart. You always choose the middle value to make the guess, and based on the information, you reduce the search space. From the developer developer point of view, the developer need to know that there is this winning strategy that will always win if user make where the user make at most 7 guesses. So from the developer point of view, you need to know binary search because you know that there is a winning strategy. So if you want your game to be some sort of challenge, some sort of based on luck, okay, you don't want a user to have a winning strategy all the time, then you should not make it to 10 trials. As a developer, knowing there is a winning strategy for 7 guesses, okay, so you will want to create. So as a developer, okay, you will want to create the game to avoid such winning strategy. Okay, so that the game is based on luck, basically. Okay, by setting the number of trials to be less than 7. Okay, because if you allow the user to make at least 7 guesses, there's a winning strategy. So every time they play, they will always win. But if you want to have some sort of luck in your game, some sort of luck element in your game, then knowing that there is such a winning strategy allows you to reduce the number of trials so that there is no such winning strategy anymore. Okay, so that's the applications of binary search. It goes beyond just searching. It's something that you need to know when you have a game like this. So is there a winning strategy? If there is such a winning strategy, you need to change the number of trials in your game so that there is the user don't always win. Okay, now that's the end for the topics for today, binary search application. Now let's do a very quick review of what we have here. So there are a couple of things I want to point out. Okay, just a very quick review. First of all, one of the quiz where a lot of students didn't score very well, and that quiz will be on iterations. Okay, so let's look at this here. So we have 2 types of iterations. One is using for loop, and for for loop, we require that when you write it, you know the number of iterations. Okay, so for example, for I in range 3, okay, and say print I. All right, this will run 3 times. Okay, for first time I is equals to 0, second time I is equals to 1, third time I is equals to 2. All right, and I is implicitly declared or initialized. So you don't have to initialize the variable I because it's implicitly initialized in the for loop itself. Okay, remember a variable, every time you use it must be initialized. However, when we come to while loop, okay, say while I is less than 3, You want to print I. Okay. Now this is the issue. Okay. So first of all, it runs infinite times. And I is not initialized. So this is a big issue. So in order for this to work, all right, we first need to initialize I to the first value of the iteration, which is 0. Okay. So this won't work. And if you want it to work, it must be that I must be initialized to the value of the first iteration. And in every iteration, you need to increase the value by 1 to the subsequent iteration. So when I is equal to 0, you print 0, and then I becomes 1 in the next iterations, and then you continue. So this is very important. So 2 things, I must be initialized and I must be increased by 1 inside the iterations. Now this will come out in the final exam, so be sure that you understand it. And that's all for today. Thank you, class. And if you have any questions, please use